Part C, which relationship has a graph you can use to find the value of x that makes 8 equal 5x minus 3 a true statement? Well, this one's kind of straightforward. There's only one of them that have a 5. And so in this case, if we come back to this work, you see this one only has a 5 right there. So we need to figure out where 8 equals, and in this case we don't have that exactly, but we need to go through and do that work a little bit. But it would definitely be plan 1 because of the 5x is already there. So for C2, we realized it was plan 1, but they want us to go through and actually look at the details to know what we would get if we had 8 in here for y. So what would x equal there? So again, this is something we're gonna get a preview on for what's coming up in investigation 3. But we have this 5x minus 3, and all this is gonna end up equaling 8. So I need to figure out, well, what's gonna be over here? I need to do this differently. So if I add 3 here, I need to keep this balanced. And again, this will make more sense when we get through this. But if I remove this minus 3 from both sides and add to both sides, this would end up being 8 plus 3 is 11 is equal to 5x. So then I would divide both sides by 5. And this x is going to be equal to, now we can't just leave this 11 over 5. We want to figure out what that work is because this is terms of number of kilometers run. So 11 divided by 5. It's going to go in 2 times. You get 1 decimal point, bring that down. And this is going to go in 2 times as well. So look at that. So actually, in this case, it would equal 2.2. That means 2.2 kilometers being run would give $8. All right, part D. The following 3 points all lie on the graph of the same plan. Now, they don't tell us which plan it is, but they start off with this one, negative 7, 13, 1.2 and something, negative 4. 2 of the points have a missing coordinate. Find the missing coordinate. Explain how you found it, then we can write a question that would go along with that to help us find the missing coordinate. Well, the first thing we need to do to figure out what plan it's going to be is go back and look at some of the data and figure some of these pieces out. Now, if I look carefully at these, can I imagine having a negative 7 here? In fact, let's just actually do that. So if I put negative 7 in for x, what would I get? Remember, it's going to end up being 5 times negative 7 minus 3. Well, that'd be negative 35. Minus 3 would be a negative 38. So it's not plan 1. We know it's not going to be plan 2 because it's always going to be 2 in this case. But let's just test it for plan 2. Negative 7 would go here for x. And I would do negative 1 times negative 7 plus 6. This would be a positive 7 plus 6 would give me a 13. So it turns out that this is the one. It is plan 2. So D1 is referring to plan 2, and that equation is y equals negative x plus 6. So we have a couple points to figure out. One, our first point is going to be 1.2. Oops, I wrote that wrong. 1.2 comma and some number. And the other number they give us is some number and negative 4. So we have a little bit of work to do to sort this out. So now we know that that's that equation. Let's go ahead and plug these numbers in. So I'm going to put 1.2 in here for this. So that's going to be y equals a negative 1 times 1.2 plus 6. Well, negative 1 times 1.2 is going to give me a negative 1.2 plus 6. Just to do that work over here, I'm going to do a 6.0 minus 1.2. So I get 4.8. So it turns out that y would equal 4.8. And so I'm going to put my 4.8 in there. The next one I'm going to do is look at trying to find x when I know the value of y. So I'm going to take this and plug that in there for y. So I'm going to have negative 4 is equal to negative x plus 6. Now this is going to be a little bit tricky here, but we want to get that x by itself. So we're going to get this out of here. So I do the opposite work that we were doing here. So what I'll do is I will actually subtract 6 here and subtract 6 here. This will cancel because those are opposites. So I'm left with, remember, same signs, add and keep. So I have a negative, oops, I did the answer ahead of time. It'd be a negative 6. So I'd have a negative 10 equals negative x. So let's try that again. I'll put that down here. Negative 10 equals negative x. Let me do that again. I think I probably threw you off on that part. So -4 minus, or -4 equals negative x plus 6. Subtract 6 on both sides. That's how we get that -10 equals negative x. I was thinking about the answer ahead of time there. Now this is an interesting answer. I don't really want to know what a negative x is. I want to know what a positive x is. So there's going to be something you're going to hear more and more about is going to be called the -1 trick. I'll multiply all this times -1 and all this times -1, and actually makes it everything switch to being a positive. So it turns out x would equal 10. So let's put that in here for our answer. Okay. That's how we would find both of those. So then what could be some questions we would come up for this, for part D2? That's what they ask us here. D2 says, write a question you could answer to find the following missing coordinate. So for this one, I'd say, well, if I, on plan to walk 1.2 kilometers, how much money am I gonna make? $4.80. Or if I end up losing $4 using this plan, how many kilometers did I walk? 10 kilometers. That's how that would work. All right, part E. Describe how a point on a graph is related to a table and an equation that represent the same relationship. Okay, so a point on a graph and the table and the equation. So if you remember, we calculated the points from the data table based on the equation. When you plot all those points, it forms this graph. All right. E2. Here we go. It says, how can you use a table, graph, or equation that represents the relationship y equals 5x minus 3 to find the value of y when x is 7, to find the value of x when y is 23. So first things, with a table, you can see that right here, this is our table from the very beginning. I can continue this part here. So I could actually say, okay, well, here's 6 and here's 7. I know that 6 would end up being plus 5, that'd be a 27. That continues here, so then 7 would be 32. And you can see how that would continue on in that case. When it comes to a graph, you can see where the ordered pair 732 would be with the blue dot up at the top of the screen. And lastly, with the equation, what we could do is take that 7 and plug it in here and actually do 5 times 7 minus 3 would equal y. This is going to be 35 minus 3. So y equals that. So y would equal 32, which is what we got here. And we saw that on the graph as well. Now for part B on E2, it says, what about the value of x when y is 23? Now that's tricky. That's gonna be right in here. When y is 23, it's gonna be in between here somewhere. So we can't get it exactly, but it's gonna be 5 point something. It's not right in the middle. It's really close to 5. So it's probably gonna be like in the 5.2, something like that. That might be my estimate, maybe my guess. I'm not exactly sure, but we'll find that out. On the graph, we can see that as we go up the y-axis to point 23 and go straight over to the line, it's a tiny bit past 5. And on the equation, what we actually would do is we would plug 23 in here for y this time. Try to figure out what 5x minus 3 would be for that. So in this case, I don't know why I put parentheses, not a big deal. I need to get this 3 out of there, so I do the opposite, add 3 on both sides. It's gonna be gone. 23 plus 3 is gonna be 26, which is equal to 5x. 5 times something equals 26. If I divide both sides by 5, this is going to be a giant 1. Let's do 26 divided by 5. It's going to go in 5 times. Hey, look at that. My guess was right. X would equal 5.2. So I know that was a lot today, and it might have been through kind of quick. We could break it into questions if you guys have. You can come to the Google Meet, and we can talk through that some more if you'd like. But really take a look at all that work that we've been doing. It's kind of culminating into one bit of activity. So how about we look at the ACE work now? So for the ACE work for this lesson is we're going to be working on 15 through 28. I know there's going to be asking you to draw graphs, and you guys don't have graph paper, but maybe you could just do a drawing of it with a ruler or the edge of your book to make it out and kind of tally it out as best you can. But here's 15. Danny earns $7.50 per hour when she babysits. draw a graph that relates the number of hours she babysits and the total amount of money she earns. So at 0 hours, she's gonna make how much money? At 1 hour, at 2 hours, 3 hours, all the way through. Choose a point in the graph, ask 2 questions that can be answered by finding the coordinates of this point. Number 16, you have part A, B, and C here. So Martel wants to use his calculator to find the value of x when y is 22. If the equation is y equals 100 minus 3x, explain how you could use each table or graph to find the answer. So how could you use all this information to find the answer to help him out? All right, 17's great question. You've got match these equations to the graphs. You got A, B, and C, but you got 4 graphs. So that means one of the graphs is not going to be used, and then whatever one's left over, you write an equation for that one. Okay. So don't forget, there's the y-intercept and the coefficient for the unit rate. Then I want you to do here for each equation for 18 to 21, give 2 values of x for which the value is negative. So make up numbers for values of x that your overall y value would be negative for all 4 of those. And 22 down to 28. I know this is a lot, but you guys are gonna do great. So you have all 5 of these equations. So which equation has a graph you could use to find the value of x that makes this one make sense? Well, match this up, figure which one it goes with. 23, find how does finding a solution for x in this equation help with finding coordinates of a point on the line that represents this equation? 24, which equation has this point on it? 25, find the following 2 points lie on a graph, 7, negative 35. Hey, it's the same one as this one. Probably find the answer. What would be the other points there? Which equation has a positive rate of change? Which equations have a negative rate of change? Which equation has a rate of change that equals 0? All right, guys. Sorry this one came out a little bit late today, but give it a go. I think if you can get stuff done, have it be due on Friday, that'd be great. But if it's a little tricky, we can definitely try to have a set talk time during our meet tomorrow. All right? Have a good one. Talk to you guys later on. Bye-bye.